Hi children, how are you all? Welcome to our new maths lesson. Today I am going to explain some more problems related to measures in motion chapter. Okay. In our last lesson we already discussed some types of travel graphs or distance time graph. Okay. So I am going to explain one another type of problem which is coming in your workbook page 24 exercise 4.3. A similar type of problem is coming in student book that I gave you as homework. Okay, if you did it you can check the answer here, or if you didn't do it will help you to do the problem. Okay, so question number 2 from workbook I am going to read. A distance time graph is plotted to represent a train's journey showing its distance from its starting point. Okay, explain giving reasons whether or not each of the graph below can possibly represent the motion of the train. So the train's journey is given in three different distance time graphs. Okay, here you have to check the graph A, B, C whether they are showing the motion of the train or not. Okay, each graph will show the motion of the train or not. You have to check it. Okay, so first we will check the graph A. In graph A you can see the distance time graph is represented by first a straight line, then a horizontal line, then again a straight line. That means graph A would represent a train traveling at constant speed, then stopping, or means it is at a rest, okay, and continuing in the same direction at a faster speed than before. Okay, so this shows graph A is representing a train's journey or motion of the train. Okay, now we will go to graph B. Graph B you can see from here. Graph B is starting from a point, then it is taking rest, then it is coming down with a speed in same time it is moving. Okay, so this vertical section would indicate that some distance is traveled in zero time. Okay, that is not possible. Okay, so after that again moving, but this vertical line at a zero time is not possible. So this graph will not show a motion of the train. Okay, it is not showing the train's journey. Understood? Now we will move to the question or graph C. You can see the graph here. In the graph it is representing first a constant speed, then it is at rest, again starting, then again taking rest, or it is stopping. Okay, then going back to the starting point. Okay, or going back. So this is showing that a train started from a place, then moved, then stopped for a time, particular time, then started again with a constant speed, then again stopped, then moved to the starting point. Okay, so this graph also will show the journey of a train or the motion of the train. So here two graphs, graph A and graph C, are showing the motion of the train, but graph B cannot represent the motion of a train. Okay, I hope you understood. Now similar type of problem is in student book. Please do it. I hope you did it before. Please check your answers. Okay. Here I am giving you one more example for the distance time graph. Okay. You can see a graph here. This is the one bus traveled from one town to the another towns. Okay. The time is given and how much they traveled also given in kilometer in the y-axis, and time is given in the x-axis. Okay, so you can see the starting point is at 10 o'clock. it started. The bus started. Okay, so it went in a constant speed. Then this is the time where it stopped. This is 10:30. Okay, 10:30 it stopped and took rest or stopped for a little time. Then again traveled to in a constant speed. Again took rest or again stopped at 11 o'clock. Then at 11:30 it moved again or it came back. It started to come back to the starting point or starting place. Okay, so this is the graph. Now we will see the questions and the answers. Okay, question number A is time of arrival at Bedford. Bedford means the place name. Okay, we will see where Bedford is coming. Bedford is coming here. So when it reached at 10:30, when it reached at 10:30, it reached at Bedford, the city or town. Okay, so what is the answer? 10:30. Now, question number B, distance from Alltown to Calbridge. Okay, from Calbridge and Alltown, what is the distance? So we will see where Calbridge is coming. Calbridge is coming here, and Alltown, where Alltown is coming down in the starting points. So what is the distance between these two? Calbridge is coming between 40 and 50. That means at 45 kilometers. So the distance between Alltown and Calbridge is 45 kilometers. Okay. Now question number C. How long at Calbridge means the train stopped. How long at Calbridge? It stopped. Okay. How long it stopped? That you have to find out. So we will see. First only I told here at 11 o'clock it stopped and at 11:30 it started again. Okay, that means it returned back. Okay, so only half an hour it stopped. So the answer is 30 minutes or half an hour. Okay, now question number D. Average speed Alltown to Calbridge. Average speed means speed we know we will find by distance by time. Okay, so you have to find from Alltown to Calbridge what is the average speed. So Alltown it is 20 plus you have to find to Calbridge how much? 45 kilometer. It traveled from Alltown to Calbridge. It took how much time? It took 1 hour, 10 o'clock to 11 o'clock, and the distance is 45 kilometers. So what is the speed? Speed equal to distance by time equal to 45 by 1 equal to 45 kilometer per hour. Okay. Now the last question E. Average speed return journey means while it returned, what is the average speed? Because it came more faster than going time. Okay, that you can see by the straight line from here to there, and it reached so fast from 11:30 to 12 o'clock. Only half an hour it took to reach the starting point. Is it? So what is the average speed? It will be more only. So how we will find it? We will find the distance traveled. It is 45 kilometer, and in half an hour from 11:30 to 12 o'clock, half an hour. So 45 divided by half. When you are dividing by half, you have to multiply, the 2 will come up, and multiply 2 by 45, you will get 90 kilometer per hour. So the average speed for returning back or return journey is 90 kilometer per hour. Okay, I hope this question also you understood this travel graph. So for interpreting travel graphs, you have to know the distance, time, and its relationship, how to find the speed, everything. So please do the left out problems in your workbook and student book. Okay. Now I am going to explain some more problems from the imperial units topic. Okay, we already discussed this topic, and here we are doing the conversion between imperial units and metric units. What are the imperial units? That are mile, yard, feet, etc. Is it? So you can see the box which I already gave last week. Here you have to select the needed information and you have to find the conversion. Okay, so here from the workbook page number 21 exercise 44.2 I am going to explain some questions. Okay, so question number 2, first I am explaining question number 2. A plane is flying at 28,000 feet. What is the height in meters? What you have to do? The height is given in feet. You have to find it in meters, or you have to convert it into meters. So from feet to meter, how you will convert? You can see the box. You can check how to convert from feet to meters. You can see 1 foot equal to 0.305 meter. This is not given in your student book. This I gave you extra. This you can by heart it yourself, or it will be difficult to change from 3 feet equal to 1 yard, then 1 feet equal to 1 by 3 yard, then substituting. By that way also you can find out the answer, but that will be difficult. So this is the easy conversion. Okay, so what we will do? 1 foot equal to 0.305 meter. Now 28,000 feet equal to what we will do? 28,000 into 0.305 meter equal to, you multiply it. So multiply and put 3 decimal places. The answer will be 8,540 meter. So we got the answer in meters. The height is 8,540 in meters. Okay, 28,000 will be written as or converted as 8,540 in meters. Okay. Next question. Question number 3. A man is 6 feet tall. What is his height in centimeters? The solution is given below. You can see feet to centimeter. So first we took feet to meter. Now you have another conversion, feet to centimeters. So from that box you will get 1 foot equal to 30.48 centimeter. So directly you can find the answer or conversion. 6 feet equal to 6 into 30.48 centimeter, because 1 foot equal to 30.48 centimeter. So 6 into 30.48 you will get 182.88. Okay, then 183 rounded to 1 decimal place. Okay, rounded to whole number. Okay, so the height is 183 in centimeters. You have to multiply and check it. Okay, now next question, question number 6. A marathon run is 26 miles 365 yards. What is the distance in meters? So here the distance is given as miles and yards, okay, together. It is not a separate unit, it is together they gave as miles and yards. So you have to convert it together to miles or together to yards, then convert it into meters. Okay, so I did one way. What I did, I converted 365 yards to miles, then the miles I converted to meter. Okay, so you can do the miles, you can convert to yards, then you can convert the yards to meters. That also you can do. Okay, so we know that in 1 yard 0.9 meters are there, and in 1 mile how many? And from the box 8 by 5 kilometer. It is kilometer, but you have to get the answer in meter. Okay, so be careful while you are doing the solution. Now 365 yards I am going to change it or convert it into meter first. So what we will do, 365 into 1 yard 0.9 meter into 0.9, you will get 328.5 meter. Okay, And next I am going to do 26 miles. I will convert it into kilometer, then I will convert it into meter. Okay, so 26 into 8 by 5 kilometer, you will get 208 by 5 kilometer equal to 4. When I did division 208 by 5, I got 41.6 kilometer. So 41.6 into, in 1 kilometer there are 1000 meters, is it? So we to convert it into meter, what we will do, we already know, multiply by 1000. Okay, kilometer to meter is multiply by 1000. So you will get 41,600 meter. Now this became 26 miles we converted into meters, and also 365 yards we converted it into meters. So add both these and you will get the answer 41,928.5 meters. Okay, you can do it in different way also. So you will get a slight difference in the answer. Okay, you can change it to both into yards, then you can convert into meters. So there will be a small difference in the answer. Okay, so I hope you understood, and similar types of problems are coming in workbook. So please do it and check your student book problems which I gave last week as homework. These types of problems, you check the answers again. Okay, so hope you understood. Thank you. So please try to complete your homeworks from the workbook exercise 4.2 and 4.3. In that, difficult problems I have explained here, and similar types you can do using these techniques. Okay, thank you. We will see in the next lesson.